I'm Kiran Kumar from Nature of Physics. Today topic is collision continuation part 3 video. Part 1 video one dimension elastic collision with basics. Part 2 video is total distance traveled by freely falling body and time taken and velocity first rebound, second, third rebounds completed student. So in this video we are going to find the final kinetic energy and kinetic energy transfer and kinetic energy retain step by step. Please do like and subscribe our channel Nature of Physics, and please watch full video, you will get clarity student. Yes, now considering a body of mass m moving with initial velocity u1 and second body is at rest student, and after collision, so first body moving with a velocity v1 and second body moving with a velocity v2. So before the collision, second body at rest, nothing but initial velocity is equal 0 taken u2. So the velocity of the mass m1 first body after the collision v1 is equal m1 minus m2 by m1 plus m2 of u1 plus 2 m2 u2 divided by m1 plus m2. But according to the question here, initial velocity of the second body is 0, so that v1 which is equal to m1 minus m2 divided by m1 plus m2 of u1, and this value u2 is equal 0 into anything 0. I can write this is equation number 1. Okay, and next velocity of mass m2, that is second body after the collision writing student. So the basic formula is v2 is equal to m1 u1 divided by m1 plus m2 minus m1 by m1 plus m2 of u2. But same condition, u2 is equal 0, so that we are getting here v2 is equal to m1 u1 divided by m1 plus m2. Now I can write this is equation number 2 student. Okay, and kinetic energy of first body after the collision ke is equal to 1 by 2 m1 v1 square student. So this is first body kinetic energy after the collision, so v1. Okay, v1 value replacing there, so that is taken kinetic energy retained by the first body after the collision is of m1. Here v1 value is m1 minus m2 divided by m1 plus m2 of u1. Whole square is there student, that's why u1 square, this is m1 minus m2 by m1 plus m2 whole square. Okay student, and now continuation I can write there kinetic energy retained is r, which is equal to of m1, this is u1 square, separately writing u1 square, and remaining value is m1 minus m2 by m1 plus m2 student. See there, just rearranging the equation. Okay, now this give initial kinetic energy of the first body because of second body at rest. So before the collision kinetic energy, we can consider this energy from RHS side to LHS side, that give the fractional kinetic energy retained by the first body. So student, so ke retained divided by initial kinetic energy, which is equal to, this is initial kinetic energy of m1 u1 square, so RHS side to LHS side, and remaining value is m1 minus m2 divided by m1 plus m2. This is I can write as equation number 3 student. Okay, and also kinetic energy of the second body after the collision, that is kinetic energy transfer to second body from the first body. So kinetic energy transfer, which is equal to of m2 v2 square, basic equation only I wrote student. Now the value is replacing, that is of into m2 into v2 value is 4 m1 square u1 square divided by m1 plus m2, because of v2 square is there student, that's why v2 square value is replacing from equation 2 student. Okay, here also one thing we can notice that kinetic energy transfer, which is equal to rearranging the equation of m1 into 4 m1. Here m1 square is there, m1 into m1 4 as usually, and now m2 into u2 square divided by m1 plus m2. Another equation also we can write from this, kinetic energy transfer, which is equal to of m1 u1 square. This is initial kinetic energy, and remaining value is 4 m1 m2 divided by m1 plus m2 student. Now same situation, this initial kinetic energy from RHS side to LHS side student. So we will get like this, fractional kinetic energy transfer from first body to second body, or fractional kinetic energy lost by the first body we will get student. Here one more step I can write there, initial kinetic energy, which is equal to of m1 u1 square student. Okay, that is next one, kinetic energy transfer divided by initial kinetic energy, that is fractional kinetic energy transfer from first body to second body, which is equal to 4 m1 remaining value m2 divided by m1 plus m2. Now I can write this is equation number 4 student. Fraction of momenta retained by the first body. Second, fraction of momentum transferred by first body to second body. Okay, that is PR represent retained by the first body. Okay, divided by initial momentum, like initial kinetic energy, initial momentum Pi, which is equal to m1 u1 student. Okay, which is equal to PR value I am replacing. Okay, that is first one m1 v1, yes, and initial momentum only for first body, that we can write m1 u1. Here see, m1 is get cancelled, and remaining value I am writing PR first body divided by initial momentum, which is equal to v1 value, writing v1 value is m1 minus m2 divided by m1 plus m2. Here u1 is get cancelled, I am not writing student, directly written. This is equation number 5. u1 common and cancel, that is in the numerator and also denominator. Okay, so this is the fraction of momentum retained by the first body student. And next one, fraction of momentum transfer. So already we have formula PT transfer by the second body to the initially momentum of the body, that is Pi, which is equal to Pi minus P1 divided by Pi student. So that I can write continuation step, P transfer of second body divided by initial momentum, which is equal to here Pi is get cancelled, Pi by Pi minus P1 divided by Pi student. So the formula is there, that is from equation 5 the value is replacing, this is PR retained. Okay student, so that is equal to 1 minus this value is m1 minus m2 divided by m1 plus m2 student. Okay, so that finally I can write P transfer to the second body divided by initial momentum. After solving this, we will get 2m2 divided by m1 plus m2. No space student, that's why written here. So this is I can write as equation number 6 student. Okay, this is clear information about the one dimension elastic collision, in which fraction of kinetic energy transfer from first body to second body and fraction of kinetic energy retained by this body. Please do like and subscribe our channel Nature of Physics.